Hello everyone. Today we will be going over factor by grouping. Okay, so I've written down the steps if you want to factor by grouping, and we'll go over those now. Okay, so your first step, you want to combine the terms into two subgroups so that each subgroup has a common factor. And we'll do those in the examples, and I'll point out each step. Okay, step 2, factor the subgroups by finding the greatest common factor of the terms. Step 3, if there is a common binomial or common factor that happens to be a binomial, factor it out. Okay. Step 4, if there is no common binomial, rearrange the terms and try again. Okay. Now, if no amount of rearranging will result in a common binomial for step 2, then it is a prime polynomial. Alright, so we're going to go ahead with our first example. If you're writing, please feel free to press pause. Okay, so for example, what if we wanted to factor by grouping? (15x to the third power) minus 10x squared plus 6x minus 4. Okay, so we're going to go through each step. Okay, so remember your first step, to make your subgroups. Alright, so I'm going to go ahead and rewrite it. 15x to the third minus 10x squared plus 6x minus 4. Okay, so we have 4 terms. So by our subgroups, we're going to make 2 subgroups. So instead of 4 terms, we're just going to have two terms with 2 each. Okay, so we have this subgroup and this subgroup. So that's what I mean by make a subgroup. Okay, so your second step is you're going to find the greatest common factor of each subgroup. Okay, so we see here that in this subgroup, you have 15, which is 5 times 3, and you have 10, which is 5 times 2, so you can factor 5 out of both of those. Okay, so you have x to the third and x squared. That's the smallest exponent, so you can factor an x squared out of both of these. Okay, so 5 times what will give us 15? 3. And x squared times what will give us x to the third? X squared times x will give us x to the third. Okay, 5 times 2 will give us negative 10, or negative 2. And x squared and x squared, you can just leave that as the same since it's the same exponent. And you can double check by distributing. So 5x squared times 3x, 5 times 3 is 15. X squared times x is x to the third. So you're good there. Minus 5 times 2 will give you 10. And x squared times 1 will give you x squared. So we're good there. Now we do the same thing here. We factor out our greatest common factor. Okay, so 6 and negative 4, our greatest common factor is 2. Okay, so 2 times 3 would give us 6. And you just have an x there, so the x stays. 2 times 2 would give us 4, so we put our minus 2 there. And again, we double check it by distributing. 2 times 3x is 6x. 2 times negative 2 is negative 4. So we're good. Okay, so you know you're on the right track when you have the same binomial. A binomial is just a polynomial with 2 terms. Think of bicycle. Binomial. 2 terms, 2 wheels. Okay, so you know you're on the right track when you have your matching binomials. Okay, so third, you're going to, sorry about that. You're going to factor out those matching binomials. So you have 3x minus 2 and 3x minus 2. You're going to bring that right out to the front. So 3x minus 2. And you can go ahead and cross that out if you like. And whatever's left goes inside the other parentheses. So you have 5x squared. And that one there, which is plus 2. Okay, so if you do the FOIL method here, you should end up with your original problem. Okay, and this is your answer. That's the factor of 15x to the third minus 10x squared plus 6x plus 4. Okay, or if you want, you can switch it around. If it's 5x squared plus 2 in the front and 3x minus 2 in the back, exact same thing. It's like multiplying 2 times 3 and 3 times 2. You'll get the exact same answer. Just switched up a little bit. All right, so hopefully that made sense. Okay, so we're going to go ahead and move on to our next example. Again, if you're still writing, feel free to press pause. Yep. All right, so let's say for example, our next example. What if we want to factor by grouping? Okay, so we have 3x squared plus 4xy minus 3x minus 4y. Okay, so remember your first step, you're going to make your subgroups. Okay, so we have our, I'm just going to rewrite it, 3x squared plus 4xy minus 3x minus 4y. Okay, and I'm going to give you a hint. You have a middle sign, you have one on the left and one on the right. When your middle sign is minus, you want to be really careful. So I'll write that. Okay, so, and I'll show you why. Be careful when your middle sign is minus. All right, so we rewrote it. Our second, well, we didn't make our subgroups yet. We'll make our subgroups. Okay, so our second step, we're going to factor both of them. Okay, so 3 and 4, you do not have a common factor for those two numerical values, but you have x squared and x, or this is just x to the first power, so you can factor out an x. Okay, so you don't have a y in both, so you can't factor that out of both of them. Okay, so x times what will give us 3x squared, 3x. And x times what will give us 4xy. Okay, so you already have the x, so you multiply that by 4 times y. Okay, so if you distribute, you have x times 3x is 3x squared, and x times 4y y is 4xy. Okay, so we're good there. Okay, now, if you notice here, negative 3x and negative 4y does not have any values in common. Okay, so if you just left that as minus 3x minus 4y, it wouldn't match up. But you can factor out a negative 1 from both of these. That's why I say you want to be careful. Because if you factor out a negative 1 times 3x will give us negative 3x. So we put 3x here because we want to get negative 3x. Okay, and negative 1 times positive 4y will give us negative 4y. Okay, so if you distribute that, you see you have negative 1 times 3x is negative 3x. Negative 1 times positive 4y is negative 4y. That's why I say you want to be careful, because when you factor out a negative 1, those signs change. Okay, and just like before, we're always looking for those matching binomials. Okay, so we have our matching binomials. Now we go to our third step, which is just a factor. And that's the easy part. Because we have our matching binomials, we can just bring that right out to the front. So 3x plus 4y, and you can go ahead and cross that out. And whatever's left goes into our next parentheses. So we have an x, and we have a minus 1. Okay, so that is our factor. Okay, so hopefully it's making sense so far. So let's go to our next example. All right, so let's say we factor by grouping. Say 2a squared plus 5ab plus 2a plus 5b. Okay, so what I want you to do, I want you to give this one a try on your own. Okay, so go ahead and press pause, and using the steps from the previous two examples, I want you to try this one. Okay, so I'm assuming you've pressed pause, you've worked this one out. So now we're just going to verify your answer. Okay, so for your first step, remember you just have to make your subgroups. Okay, so yeah, I'm just going to go ahead and rewrite it. So you have 2a squared plus 5ab plus 2a plus 5b. Okay, and here are our subgroups. Okay, so we got our 4 terms, broke it down to 2 sets of 2 terms. Okay, so now we have our second step. Okay, where we go ahead and find we go ahead and factor them out. Okay, so we know for 2 and 5, the only value they have in common is 1, so we don't have to worry about that. Okay, you have a squared and you have a, which means you can factor an a out of both of those. Oh, put it on the other side. There we go. Okay, so you don't have a b in both, so you can't factor a b out. Okay, so a times what would give us 2a squared? A times 2a. Okay, so you can always double check. A times 2a is 2a squared. Plus, let me straighten out that a. It's bugging me. There we go. Okay, so a times what will give us 5ab? Well, if we distribute, we already have the a, so it's just going to be 5b. Okay, so if we double check it and distribute, a times 2a is 2a squared. A times 5b is 5ab, so we're set there. Okay, so if we look at these two, the 2 and the 5 don't have a value in common, so there's nothing to factor out there. You only have an a here, you don't have an a there, so you can't factor out an a. You don't have a b in both terms, so you can't factor out a b. The only value they have in common is 1. Remember, when there's no greatest common factor, that greatest common factor is equal to 1. Okay, so that means you're just left with 2a plus 5b. All right, so just like before, we have our matching binomials. Okay, so our third step, we just go ahead and factor. Oh, factor both. And this one is just factor outright. Okay, so we have these two matching, so we can go ahead and bring those out to the front and cross them out. 2a plus 5b, and whatever's left goes into the other binomial. Okay, so you have a plus 1. And that is your answer. All right, so we're going to go ahead and go to our next example. Excuse me. Okay, so what if we want to factor by grouping? Say 3xy. Yeah, that 3 looks a little bit messy there. There you go, 3xy plus 2 minus 3x minus 2y. Okay, so remember your first step. Well, actually, I want you to try this one because it's a little bit of a trick to it. And see if you can remember, go back to the list of steps and try to solve this one. Okay, so go ahead and press pause and give this one a try. Alright, so we're going to go ahead and solve this one. Okay, if you got stuck, don't worry. This one's a little bit tricky. That's why I wanted you to try it first. So you know if you ran into a problem like this, if I've experience with it, you'll see how it looks to solve it. Okay, so we make our subgroups. Okay, so we have 3xy plus 2 minus 3x minus 2y. All right, so our second step, we factor both. Okay, so we make our subgroups here. Remember that middle term is minus, so you want to be careful with that one. All right, so we have 3 and 2. There's no value in common for that one. We have an x here and no x there, so we can't factor out an x. We have a y here but no y there, so we can't factor out a y. So our greatest common factor is just 1. So you have 3xy plus 2 times 1. So if you distribute, you just end up right back with that one. Okay, remember that middle term is minus, and you want to be careful with those middle terms of minus, or middle signs of minus. So there's nothing in common here, so the only thing we can factor out is a -1. Okay, when you factor out a -1, you have the sign changes. So you have positive 3x plus positive 2y. Okay, so you see here, binomials do not match. Okay, so if they do not match, we cannot factor. Binomials do not match. Okay, so when your binomials don't match, that means we have to rearrange the terms. Okay, that was one of the steps. That's one of the problems you might run into. Okay, so that means we move that up a little bit. We rearrange the terms. Let me separate that. That means 3xy plus 2 minus 3x minus 2y. Let me straighten that out a little bit. There we go. Becomes, okay, you want to put two terms next to each other that has a common factor. So 3xy, I'm going to put that one next to the 3x. Okay, so we have 3xy, move the sign and everything. So if it's minus 3x here, it has to be minus 3x next to it. Minus 3x. Okay, so you can make it plus 2 minus 2y, or just make it minus 2y plus 2. Okay, now once you rearrange it, that means you have to start your steps all over again. Because it didn't work the first time. So that means you're restarting your steps because you've rearranged it and you're going to try again. Alright, so let me move that up a little bit. Okay, so remember your first step. You factor. So I'm going to go ahead and just rewrite it so I can do all that. 3xy minus 3x minus 2y plus 2. Okay, so your first step are your subgroups. Okay, now your second step is you're going to factor both. Make a little arrow there. Okay, so you can factor a 3x out of both of these. So you have 3x. Okay, 3x times what gives us 3xy? So 3x times y. 3x times what gives us negative 3x? That would be -1. And again, if you go ahead and distribute, you'll see that you end up right back where you started, which is what you want. Okay, so you have -2y and positive 2. Remember, when that middle term is negative, you want to be careful. Okay, so you have -2y plus 2. We can factor out a -2 from both of those. Okay, so when we factor out a -2, -2 times what will give us -2y? -2 times positive y. And -2 times what will give us positive 2? -2 times -1. Okay, so now we have our matching binomials, which is exactly what we want. Okay, so we have our matching binomials, which means we go right to our third step, and we're running out of room, so I'll try to get everything. I'll do our third step over here. Okay, so you have your matching binomials, so you just bring that out to the front. So you have y minus 1 and y minus 1. You can go ahead and cross cross that out. And whatever's left goes into the next binomial. So you have 3x minus 2. Okay, so you have 3x minus 2, and that is your final answer. Alright, so we're going to go ahead to our last example. Okay, if you're still writing, please feel free to press pause. Okay, so let me go ahead and move that back down. Okay, so let's say if we wanted to factor by grouping. (5x minus 10 plus x to the third minus x squared. Okay, so remember your first step. You want to get your subgroup. Okay, so you have 5x minus 10 plus x to the third minus x squared. And we can go ahead and make our subgroup. Okay, so your second step, you're going to go ahead and factor both. All right, so for these two terms, you can factor out a 5. All right, so once you factor out your 5, 5 times what gives you 5x? That's 5 times x. And 5 times what gives you negative 10? That would be minus 2. Okay, so now we go ahead and factor from these two. You have x to the third and x squared. Okay, so you can factor out the smallest exponent, which is x squared. Okay, so x squared times what gives you x to the third? That would be x squared times x. And x squared times what gives you negative x squared? That's minus x squared. Okay, so we can see here that these do not match. Oh, sorry about that. U1 here. Okay, so those do not match. Okay, so we rearrange our terms. Okay, so we go ahead and separate that. Okay, so what if we try making it x to the third plus 5x minus x squared minus 10. Okay, so we just go ahead and rearrange our terms. Okay, so we rearrange our terms and we do our steps again. So we do our first step, which is our subgroup. Okay, so we make those into two subgroups. Then we do our second step, which we factor both. Okay, so that means we end up with x coming out of both of those terms. Okay, so x times what gives us x to the third? X times x squared. Okay, and x times what gives us 5x? That'll be plus 5. Okay, so these two terms, remember you have a middle term that's minus. So the only thing you can factor out of those two would be negative 1. And when you factor out a negative 1, your signs just change. So negative x squared becomes positive x squared. And negative 10 becomes positive 10. So once again, these do not match. So you can't factor them out. Okay, So just so happens for this particular problem, no matter how many times you rearrange the terms, you will not get a common binomial when you factor, when you do that second step. Okay, so when you have that, and you have no matter what you do, you will not get that common binomial, you have a prime polynomial. That would be your answer. It's prime or prime polynomial. Okay. So no matter how you rearrange the terms, the grouping will not lead to a common binomial. Okay, so this is a prime polynomial. Okay, so that would be your answer, either prime polynomial or just prime. Okay, so hopefully this made sense, and I will see you on the next video.